All right, so this is part 2 of similarity and congruence. We've just got done proving similarity, the fact that we need to have all the angles to be the same between the shapes and all the sides need to be proportional. We saw some shortcuts we can use for triangles. Okay, the extension is when shapes are congruent. We learned earlier when we talked about scale factor that for congruence, they have to be a scale factor of 1. Right? And that makes sense because 5 times 1 is still 5. It stays the same. It does not change. Congruent means that the shapes are same. Okay, so if you need help with similarity, go see the video from before or the lesson from before. Right. So once again, required topic is the 3 sides. The basics is 3 sides, 3 angles. Okay, so all 3 sides are proportional with a scale factor of 1, then the 3 corresponding angles are going to be congruent, and that means overall the 2 triangles are also 100% congruent. Okay, to show this, we must give evidence of the 3 sides that are proportional and prove that they have a scale factor of 1. Okay, so we just list it down just like this. So side 1, 5 and 5, we match them up. 5 times 1 is 5, so that's my evidence. Side 2, 7 times 1 is 7. And then side 3, 10 times 1 is 10. Boom. Okay, so not a big deal. We just got to state the facts so I can give you evidence that what I'm saying is not just random stuff, but there's proof for it. Okay. The evidence above shows that the triangle are congruent, and this is called side-side-side congruence. Okay, next one. Okay, this one's a little bit more complicated, but it's still based off of the previous similarity exercises that we did. Okay, so angle, angle, angle by itself does not give us enough information for congruence. Okay, because congruence needs a scale factor of 1. Okay, angle, angle, angle doesn't give us any sides to compare, so we need at least one side to be able to compare, and that scale factor has to be 1 for them to be congruent. So if all 3 angles are congruent, then all 3 corresponding sides are proportional. That's good. We got that from similarity. The added thing is for congruence, we need to show at least one side is a scale factor of 1. Because if one has a scale factor of 1, because they're proportional, they all have that same scale factor. Okay, cool. So first off, we got to prove that they're similar. We have 3 angles that match. The 50 matches the 50, the 60 matches the 60, the 70 matches the 70. Find this in here. So 70 matches 70, 50 matches 50, and 60 matches the 60. Okay, so that proves to everyone that these shapes are indeed similar, and that similarity rule is called angle, angle, angle similarity. Okay, next thing we got to find out is that they have a consistent scale factor of 1. Okay, this is where that side angle relationship is super important. Okay, I can't just willy-nilly choose any side. I have to make sure it's a corresponding side. To find corresponding sides, I notice the angle and I look across from it. So across from the 60 is a 6 times a 1. And across from the 60 in this other triangle is a 6 also. Okay, so 6 is equal to 6. Okay, you have to make sure they're across the same angle. Okay, otherwise it doesn't matter. If you have a 6 across the 70 and a 6 across the 50, those are not congruent. Okay, they're not necessarily congruent, I should say. Okay, so it has to be across the same angle, otherwise it doesn't count. It has to be across the same angle. Okay, because the 6 is across both of the 60s, we know these have to be congruent, and we're done. All right, so the next part is extra. That's as far as it gets for the passing the class. Okay, so if you're interested in getting an A or B, stay with me. Okay, so for an extra credit of an A or a B, you also have to show how the shortcuts we just did lead us to the ideas of HL, which means hypotenuse leg, angle, angle side, and angle side angle. Okay, so I'm going to go back and walk us through that. Okay, so this one's pretty straightforward. If you've been following along and you understand the Pythagorean theorem, this one should make sense to you. If you know 2 sides of a right triangle, right, HL is, there's an H because we have a hypotenuse. Hypotenuse is always across a 90, right? And so if you have a 90-degree triangle, then you can use the Pythagorean theorem to find the third side. And if we have 3 sides, then we can prove that they're congruent, right? If 3 sides match, then the other 3 angles have to match also, and these triangles will be congruent. So we still have to prove that. Even though you might get that, you have to give the evidence. Okay, so side 1 is the hypotenuse. It's 5 for both triangles. 5 times 1 is 5, so that works. And then side 2 is 4, the blue one. 4 times 1 is 4, so we just showed that a leg and a hypotenuse are the same. We can use the Pythagorean theorem to find the third side. The third side has to be 3. And we just saw that the scale factor is always 1. And so we use HL, the fact we have a hypotenuse leg, through the Pythagorean theorem to prove that all 3 sides are congruent. Okay, so for those of you guys that understand this, you don't actually need all 3 sides anymore. 2 sides where one is across the 90-degree angle is enough, right? If you have 2 congruent sides where one of the sides is across from the 90-degree angle, it has to be the same side both times, like 90 goes to 5, 90 goes to 5. If it was a 90 and then a 4, then that's not congruent, right? 90 always has to go to the same number for them to be congruent. Okay, so that's how HL works. And then this one is very similar. Let's go through it. So both of these are based off of angle-angle similarity. The first one we're going to talk about is angle-angle side. Okay, so notice the side is outside of the 2 angles. So it's not inside or in between the 2 angles. It's next to the 2 angles. So we have the 60, the 50, and then the 6. We have the 60, the 50, and then the 6. Okay, and notice the 6 is next to the 50. It's not next to the 60. Okay, it doesn't switch which ones it's next to. So that's, once again, that side angle relationship. It's consistently across from the 6. Okay, we know the one across from the 60. We know the one across from the 60. And then we have 2 angles there. All right. So the rule is, if we're given 2 congruent corresponding angles and the side next to a corresponding angle is congruent, okay, then the triangles are congruent. Okay, and the way this works is because of the triangle sum theorem. Okay, so we know that 50 is the same as 50. That's our angle 1. Angle 2 is 60. Even though this sounds silly, you have to give the evidence. Okay, this is how everything works. Law works this way. You have to provide the evidence. You have to have the convincing argument to prove your point. Okay, and because of the triangle sum theorem, we can calculate the third angle, which will be 70. Okay, both of these triangles have 50, 60, and 70. Therefore, they are similar automatically. So now we have to show the scale factor. Okay, so once again, you have to use the side angle relationship. We notice that across from the 60 is a 6, and across from the 60 is a 6 times 1. Okay, so that is true. They are congruent to each other because the scale factor is 1. So the next one and last one is angle side angle. Okay, hopefully you're following along. Notice that this side is not next to the 2 angles, it's in between. Okay, that's the difference. Okay, so if you have 2 angles and a side across from the same angle, right? This side over here is across from the 60, just like it was last time, right? If you have it across from the same angle, then automatically they're going to be congruent. Okay, but the shortcut for this one is, if given 2 congruent corresponding angles and the side in between is also congruent, then the triangles are overall going to be congruent. Okay, so the evidence for this is, we have the first angle, we have the second angle, the third angle will be the same because of that triangle sum theorem, right? The third angle has to be 60 because 60 plus 70 plus 50 does give us that 180 degrees. Okay, so the evidence above, we just showed that these triangles are similar. Now we have to show that they're proportional with a scale factor of 1 to prove that they are congruent. Okay, so we have the 50 and the 70. The one here would be 60. Across from the 60 is a 6. We have the 50 and the 70. This would be the 60. Across from the 60 is a 6. So these are indeed congruent, right? Because 6 times 1 is 6. Okay, so that's it. Thank you.